The reason for seasons. As we discussed, seasons are caused by Earth's tilt. What we haven't discussed are the differences in weather and temperature that are associated with seasons. We all know that there are certain weather patterns and types of weather that go along with winter, fall, spring, and summer. So we'll look at the three factors that control the characteristics of seasons. First, direct and indirect rays. Watch this animation of a flashlight. At the higher angle, the flashlight is making a smaller circle. The smaller circle is more intense than when the flashlight's at a lower angle and has a wider circle of light. If you can take that same thinking and apply it to the sun, the higher the sun's angle, the stronger the sun's rays. These are called direct rays. Conversely, the lower the sun's angle, the weaker the rays, and we call those indirect rays. So on December 21st, the northern hemisphere receives indirect rays, lower angled sun rays. On June 21st, the northern hemisphere receives more direct rays, which are more higher in value. So that's the factor that really controls the intensity of sunlight that we receive. Next, the noon sun position. The noon sun, except for maybe the North Pole and the South Pole, is the highest point or highest position the sun will get for any latitude throughout the day. When the sun is at its noon position, that's when it's giving the most direct rays for that day and the most intense rays. Certain locations actually receive 90-degree rays when the sun is directly overhead. We call that at zenith. For our latitude and actually most latitudes, this is never the case. The only places on Earth that actually have a sun angle of 90 degrees directly overhead are the tropics and the equator. So between the Tropic of Cancer, the equator, and the Tropic of Capricorn, the sun is overhead throughout the year. Starting June 21st, it's the Tropic of Cancer, then it's the equator, then it's the Tropic of Capricorn, back to the equator, and eventually back to the Tropic of Cancer for June 21st again. So the sun moves through these three lines of latitude and any latitude in between where it's directly overhead, giving the most intense rays possible, which kind of makes sense. We call these areas the tropics because of the temperature and the climate that they have due to the sun being directly overhead. The last factor, the length of the sun's path. If we were to compare the length of the path the sun takes during spring, autumn, winter, and summer, it's much longer in the summer and much shorter in the winter. And that really has an impact on how much heat is delivered by the sun because of how long the sun is out. The more hours the sun is in the sky, shining on a location, the more heat it will receive. The less hours that it's out shining, the less amount of heat it's going to receive. So longer path equals more heat, shorter path equals less heat. While we're looking at this diagram, I do want to point out something. There's a stick here showing the shadows produced from the noon sun. Turns out that this diagram is showing the noon sun position, right? The sun is at its highest point in the middle. Well, shadows really come into play when the regents ask questions, and you'll see them on Castle Learning and potentially on our next test. And to actually demonstrate this, I want you to do a quick experiment on your own. Take you 2 minutes. Using an iPhone and a pencil, I want you to set it up so that the iPhone's flashlight, the actual flash for the camera, is shining at the pencil. And hold the pencil upright, maybe a foot apart. Change the angle of the iPhone to a much higher angle and see what the shadow looks like of the pencil, and then move it back down to a lower angle and look at the shadow of the pencil. And compare the two. When is the shadow shorter? When is the shadow longer? So what you probably noticed from your quick experiment is that the lower position of the iPhone, the flashlight, whatever you used, produces a much longer shadow, and the higher the angle of the flashlight, iPhone, whatever you used, produces a much shorter shadow. This is going to be important for the next couple of slides that I'm going to go through. If you can remember that, lower angles produce longer shadows and higher angles produce shorter shadows, it will all make sense in the end. So to finish this video, I want to kind of introduce you to a celestial hemisphere. It's a way or a method of modeling the sun's path in New York State or any location. A celestial hemisphere looks like this. It's a plastic dome. It's clear, and you can write on it. And really, it's used for two things. One is measuring the sun's path or the sun's arc, and the other one is measuring the angle of the noon sun for any time of the year. So let's first take a look at how we can measure the sun's arc. So this is our model for this video. In class, we'll be using an actual plastic dome. It all works the same. So in this celestial hemisphere, there are 3 sun positions. You can see the 3 dots. Those represent the seasons. The noon sun position for the winter solstice, the equinox, and the summer solstice. The equinox obviously being repeated. Shown also are the paths or the arc the sun takes across the sky. So starting, for instance, for the summer solstice, starting in the northeast and then ending in the northwest. For the equinox, starting in the east, ending in the west, and then the winter solstice, it's south of east and south of west, showing the path the sun takes. Now, if I were to look at those 3 lines and compare them to each other, obviously the red line is going to be much longer than the blue and the green. So that shows that the arc is much longer, so the path is much longer, therefore there's more hours of light. You could also measure in degrees what that length is, and if you have it in degrees and you divide by 15, you can actually calculate how many hours of light exist. The other technique used with a celestial hemisphere is to measure the noon sun angle. So this is a completed celestial hemisphere showing the 3 paths of the sun for the 4 seasons, and you can see the small circles representing the noon sun position for each of those seasons. Using that information and the external protractor shown in this diagram, we can see how high above the horizon the sun is. So for instance, using my same model from before and a version of an external protractor, I can measure going upwards that the winter solstice is about 24, 25 degrees. The equinoxes are about 48, 49 degrees, and the summer solstice is about 71 degrees. So another useful tool that the celestial hemisphere can provide is measuring the noon sun angle. So to demonstrate how this all kind of plays into the actual path the sun takes, I have 4 animations to demonstrate the path of the sun and how our shadow is actually affected by where the sun is. Remember back when we did that quick little experiment with the iPhone, the lower the sun, the longer the shadow, the higher the sun, the shorter the shadow. So let's look at this. The sun's rising right now in the eastern part of the sky. Right, it reaches a noon sun angle of 48 degrees. My shadow has changed its direction. Originally it was pointed to the west, now it's pointed to the north. And as the sun sets in the west, it'll be pointed to the east. So a couple of quick things about shadows. Our shadow always points opposite the direction of the sun. Okay? And our shadow is always longer in the morning and shorter at noon, but only to grow again when the sun sets, because the sun's at a low angle during sunrise and sunset. So that's when our shadow will be longer. And at noon, our shadow is always going to be a little bit shorter because the sun is at a higher angle during that time. All right, let's look at the June 21st, 22nd summer solstice. Much longer path. Here's the sun rising from the northeast, hitting an angle of about 71.5 degrees. Notice the noon shadow here is very short. That's a famous question. You might see it on a test or a quiz or on a Castle Learning or on the Regents. When is your noon shadow the shortest in New York State? You would say June 21st, because the sun's at its highest angle, producing the shortest noon shadow. And then the sun sets north of west. This is a repeat of before. The March 21st, 22nd spring equinox is the same as the fall equinox, so everything that I'm showing you here is a repeat. Okay, and then finally, our winter solstice. Our shadow much longer for this sunrise because the sun's much lower than it normally is. And at noon, another famous question, when is your noon shadow the longest during the year in New York State? You would say December 21st, because the sun, while the noon position is its highest position during this day, it's still very low in the sky, producing a longer shadow. And then the sun sets south of west. Okay, there's a lot of information there, and I'm aware of that. That's why having it in a video allows you to go back and review it as many times as you need. But I also have this chart that I wanted to share with you. So if you need to refer to this chart at any time, you can always go back onto Edpuzzle, hit pause, and have this video, chart visible for you so that you have the information you need. So starting at the top, it says season, date, sunrise, sunset, hours of daylight, noon sun angle, noon shadow. So our spring equinox happens on March 21st, 22nd. The sun rises in the east, it sets in the west. We have exactly 12 hours of daylight. The sun reaches an angle of at noon at 48 degrees. And our noon shadow, there's really nothing significant to say, so that's why I left that cell blank. The summer solstice is June 21st, 22nd. The sun rises north of east. It sets north of west. And we have about 15 to 16 hours of daylight. The noon sun angle is about 71.5 degrees. And on this day, our noon shadow is the shortest that it will be at any time during the year at noon. And then our fall equinox is the same as our spring equinox. And then finally, our winter solstice on December 21st, 22nd. The sun rises south of east and it sets south of west. We have 9 hours of light on this day, and our noon sun angle is 24.5 degrees. And the shadow that's produced at noon on December 21st, 22nd is the longest at noon for the entire year. All right, so that does it for our discussion of seasons. Thanks for watching.